Hello everyone. So I have a plastic bottle here, and when the bottle had its wrapping thing, whatever you call it, around here, the label, it said it was 16.9 fluid ounces, but I think a lot of people misunderstand what that means. They think that's a weight, and it's not. Fluid ounces is a volume. And so, say it was full and you weighed it. It's not necessarily going to weigh 16.9 ounces. I mean, it could, but that's not what that means. It's basically like how much the container can hold. So, you could put water in here, soda, cement, whatever. It's still 16.9 fluid ounces, again, because it's a volume. And then it'll weigh however much it'll weigh. So I think a lot of people have that confused. This one did have water in it. Other than that, I don't know the other dimensions of it. I can measure it. See what the length is here. About 8 inches. I don't know if you can see that. It's about 8 inches in length. And surprisingly, also about 8 inches round too at its widest point. They make it a little bit smaller here in the middle, I guess, so you could put your hand around it or something. Let's see what that is. I'm going to say, I don't know, probably 6, 7, so an inch less around the smaller point. What was I going to say? Oh, I have a scale here too. Let's weigh it. Let's weigh it here. Probably weighs like a couple grams, 10 grams. So yeah, any of the measurements I give, if someone can convert those to metric, because the majority of people in the world use metric, and, not necessarily going to be from the United States. But yeah, just a regular plastic bottle. It's really interesting. Like, watch. So I took the cap off. And I squeeze it really easily. I could crush the bottle if I wanted to, right? Put the cap on. Now, squeezing my hardest, and I can't crush it. Why? Well, that's because the air pressure. There's air in the atmosphere, or whatever, pushing down on it, but there's also air inside, basically pushing away, outwards, and that pressure is strong enough, the air that's inside is strong enough to prevent me from squishing it. But obviously, if I open this up, now when I squeeze it, there's still air inside, but now I squeeze it and then the air can just come out and go, wherever else. But when it's closed, air has nowhere to go, so it creates opposing pressure. Probably not going to pop, but yeah, I can't fully squeeze it, and you see how hard this is. So now you're thinking, okay, is that why when you have a container of soda that it's really hard? Yes and no. It is air. Well, it's not air, actually, it's carbon dioxide. That's why sodas have fizz, it makes you burp, all that kind of stuff, because they load it up with carbon dioxide, and all the pressure from that carbon dioxide, again, pushing out against the walls of the thing, make it really tight. So you go to a soda bottle and you press it, it's really tight. And now, the third thing, a bag of chips, also, you notice, has a little bit of pressure too. It's not very hard. You could probably squeeze it and pop the bag of chips, but that's nitrogen. That's not carbon dioxide. And that's meant to keep the chips fresh. There you go. I learned a little bit about bottles.